This week is all about statistical variability, specifically in 6th grade. We've got 3 6th grade standards for statistical variability. One about recognizing what kinds of questions are statistical, and then two that deal with center, spread, and overall shape, measuring center and measuring variation. So first off, recognizing a statistical question. We did a little bit of that last week, but this set of questions, we're going to identify, is it statistical and can it be rewritten to be statistical if not? So first off, what's the name of a frog? No, that's not a statistical question, and it can't really be rewritten. Another question, what is the typical jump length of a 4-inch frog? Yes, this is statistical. We could collect a bunch of data and calculate measures of center and measures of spread and figure out what typical might mean in this case. How old are you? No, this is not a statistical question. This is the type of question that students get very confused about. It seems like it's a question collecting data. So why is it not statistical? Well, it's not got variability. It's only one piece of data. So to change it, how old are the students in your school? How many books does each student in your school read this year? This is statistical. We can collect many data points and measure. How many days are in a week? No, this is not statistical and it can't really be rewritten. What is your favorite color? No, that is not statistical. Better written, what are the favorite colors of students in your class? Again, this is one that students get confused about because you might ask that question when you are collecting statistical data. Okay, measures of central tendency. These are the measures of center, single values that mean, that have the meaning of what is the most typical or middle of a set of data. And these are mean, median, and mode, the 3 M's. So mean is also known as the arithmetic average. We use the word mean rather than just the word average because there are other types of average. For example, the geometric average or the geometric mean. So anyway, one way to compute mean is adding and dividing by the number of elements that we have. The important thing to remember when dealing with mean is that it truly is the best measure of center if the data does not contain outliers, numbers that are way smaller than the rest of the data or way larger. And when those are included, that skews the data, and the data ends up being not symmetric. And the mean is pulled from one direction or the other, and not a true measure of center. Here's an example. Suppose the following data set about baseball scores. Add the numbers and divide by 7. I just wanted to point out notation here. Notice that we have the divide by 7 given here. A lot of times teachers, all kinds of folks, will put false statements on the board, false equalities. They'll list all of these numbers and then write equals 109. Then proceed to put divided by 7 and finish that up. If there's not a divide by 7 here, then that is false. The sum here is not the same as that sum divided by 7. So if that were what you wanted to write, you need to rewrite 109 out here with the divided by 7 and make that a separate inequality. All right, so median, the middle number of the set of data. When there's an even number of values, the median is the average of the two middle numbers. And this is a measure of center that is better used, better than the mean, if there are outliers or if the data is not symmetric. Median works out better. Just like in housing data. Median is really useful because if there's a huge mansion in the middle of a bunch of houses, that would skew the seeming center or average price. And so median is a much better idea of housing prices. So here's an example. After the data is arranged in order, the middle number here happens to be 15. And because we have an exact center, if we were to add another number here at the end and make that an even number, then our center lies between 15 and 16, and that makes 15.5. The average of those two, the mean of those two, are new value. The mode is the number that occurs most often. Some data sets have more than one mode. Some data sets do not have any mode at all. You can have bimodal or even trimodal sets of modes in a set of data. Here's the same example again. The mode in this case is 9 since it occurs twice, and there are no others that occur more. The next section, measures of spread, range, quartiles, interquartile range, mean, absolute deviation, and shape. So the range is a set of data that is the difference between the minimum and the maximum values. And this is a way to measure spread. Minimum and maximum are part of the 5-member summary measuring spread. Suppose we have this data set. Easiest first to place the data in order, and the range ends up being the largest, the maximum, 43 minus the minimum 2, for a range of 41. Quartiles. Once the data is placed in order from smallest to largest, we divide the set into 2 halves. If it's an odd number, the median is not included in the lower or upper half when finding the first and third quartiles. If it were an even number, then the median would be the average of those 2 values, and those 2 values would be included. So the first quartile is the mean of the lower half, and the third quartile is the mean of the upper half. Interquartile range is the measure of spread of the middle of the data. It is found by taking the difference of the third and first quartiles, the third quartile minus the first quartile. Statisticians really like using the IQR to measure because it is not very much affected by outliers or non-symmetrical distributions. So this page finishes up our 5-number summary. The first 2 being on the previous page, our minimum and maximum values, and our median, and our first and third quartiles make the 5-number summary describing the spread of data. Next, the mean absolute deviation. Mean for average, absolute for absolute value, so we make everything positive or based on the distance from the center, and deviation referring to how far apart the data is. So you start by finding mean, and then you compare how far the data points are. So the one on the left, the data is a little bit closer to the mean, the x's, and then this one, they're a little more spread out. Therefore, the mean absolute deviation of the left would be a smaller value and a greater value on the right. So here are the steps for calculating mean absolute deviation. First, you calculate the mean of your data set. The mean in this case is 57. So here's all the data values. So you list data values in our first column. Then we subtract the mean from each of the values. And so we've got some negative values and some positive values. Always, if we were to find the mean of this column, we would get 0 because it's the same distance on either side since we're dealing with the mean. So to get an actual measure of spread, we need to take the absolute value of each of these, and that's what goes in our final column. And then after we take the sum and divide that by the number of values, there are 10 values in this case, so our mean absolute deviation is 7.2. Well, this is not writing this. 7.2. It is not writing for me. There, that's a little bit better. Okay, our final topic here is shape. These vocabulary terms up here are those that are used by statisticians to describe the shape of a spread of data. And one of the best ways to look at shape is by looking at a histogram. A would be what we consider uniform. I tell my students if it looks really close to a rectangle, more rectangle than anything else, then you can call that uniform. Sometimes the distribution has more than one name. B, I would call both double peaked. There are two taller pieces, and symmetric. It's relatively symmetric. A line of symmetry right down the center. Picture C could be considered single peaked and symmetric, and picture D has a slanted triangle kind of shape, and that is typically considered skewed. And it's also got a single peak, so that one could have two names as well. So that gives us our overview of our measures of center and our measures of spread that are focused on in grade 6. Thank you.